Alright, welcome back to another video on my channel, math_exe. Today we're going to look at volume and surface area of prisms. So we're going to talk about what prisms are and the formula for the volume of a prism. So a prism is a 3D shape that is formed by extending a polygon perpendicular to the surface of it. So here is a example of a prism. So notice that we have a polygon right here. A polygon right here, which is shaded in red, and then it is being extended perpendicular to the surface of it. So it is being extended three-dimensionally. So that's just the definition of a prism. So the volume, or the definition of a volume, is the amount of three-dimensional space inside. So the volume of a prism is defined as the area of the polygon that is extended, which is the one shaded in red here, which is also commonly known as the base. So we have the area of that base times the length of the extension of the polygon, meaning how long is this prism being extended to. So in simpler terms, V, which is volume, is equal to A, which is the area of the polygon or the area of the base, times L, and L is the length of this extension. So let's just define some formulas for the volume of some prisms that are very common to appear. So first thing is the rectangular prisms, also known as the cuboid. So here we have dimensions A, B, and C as our sides, and using our formula that the volume of a prism is the area of the base, which, let's say I'm just going to choose this one. So we need to find the area of that green region times the length of extension. In this case, this is C. Now notice that the green shaded region is a rectangle, and the formula for the area of a rectangle is base times height, which is A times B. So if A times B times C, or ABC. And fun fact, if A is equal to B and is equal to C, meaning all of these three sides are equal, then this rectangular prism is a special prism, and it's special, that is, has a special name called a cube. So let me just draw a cube right here, although this won't be perfect. Something like that. So the second one, we're going to derive the formula for the volume of a triangular prism. So again, using our fact that the volume of a prism is the area of the base times the length of the extension. In this case, the area of the green region times C. And the area of the green region is a triangle, and the area of a triangle is base times height, which is a half times AB. So the formula will be a half ABC. There we go. And lastly, although some of you may disagree that cylinder is a prism, well, a cylinder is a prism, quote unquote a prism, that has a face in the shape of a circle. And based on our definition of a prism, it says a 3D shape that is formed by extending a polygon. And a circle is not quite a polygon, so theoretically this is not a prism. But I would say this is almost a prism because it almost looks like one. So that's why I'm adding this to the list. So using the fact that the volume of a prism is the area of the base, which is shaded in green here, times the area extended, which is h in this case. Notice that the green region is a circle, and the area of a circle is pi times the radius squared, which is pi r squared in this case, times h. So these are how you can get the formulas for most of the prisms. And with this in mind, we're just going to talk about area later. Let's jump into the first question, which is mainly for volume. Right, for question 1, we need to find the volume each figure below. So we have 3 figures right here, and let's start off with the first one. The first one is very easy because knowing that the fact that the volume is equal to the area of the base times the length extended, and the area of the base is already given, which is 72 centimeters squared, and the length extended right here is 10 centimeters, which in total will be 720 centimeters cubed. And the quantity used, or the units used to measure volume, is centimeters cubed, or meters cubed, or inches cubed, or pretty much anything cubed, or anything to the third power. So for B, this is a prism with its base being a trapezoid. So let's just write our formula for our volume, and let's figure out the area of a trapezoid here. So recall that it is a half times the sum of the parallel sides, which are 6 and 10. So let's just write that down. Multiplied by the height of the trapezoid, which is 5. And all along that, we need to multiply by the length extended, which is 20. Working things out, notice that we can cancel a 2 here, replacing it with a 10. We know 6 plus 10 will be 16. 16 times 5, which will be 80. And 80 times 10 will be 800. Yep. And for C, well, we can just use our formula again. And this time we need to find the area. Well, notice that the area of this base is actually the area of a square plus the area of a right angled triangle. And I forgot to label that. There we go. And also this is a square as well, multiplied by the length extended, which is 40 meters. Now the area of a square is just the length of its side square, which will be 10 meters squared, which will be 100 meters squared. The area of a triangle is the base times height. And in this case, the base and height are both equal to 10 meters. So that will be half times 10 times 10, which will be 50. So this will be 50 meters squared. All of that multiplied by 40. We know 100 plus 50 will be 150 meters squared times 40 meters. That will be 6,000 meters cubed. So the area of this figure will be 6,000 meters cubed. Right, so let's just take a break from some questions and let's talk about surface area of prisms. Alright, we're going to talk about surface area and nets now. So surface area is, well, quite explanatory. Is the area of the surface of any 3D shape. While nets in this geometrical context are arrangements of non-overlapping plane figures. So for example, you cannot like put a plane figure on top of another. So we have non-overlapping plane figures that are joined by their edges, which can be folded to make a 3D shape. And an example of a net is as shown here. This is a net of an octagonal prism, which is a prism with a base of a octagon. And this is not the only valid net for a octagonal prism. There are actually more. So you can just like play around with this game of finding the nets of prisms and stuff, and let me know your results in the comments below. Nets are actually very useful to calculate surface area, as it gives us a better perspective of viewing the surface area of the prism itself. So you don't really need to worry about looking at the prism in a 3D perspective, where you can just unfold it and just calculate the areas of each polygon itself. So in this case, you can just calculate the squares and the octagons there. The surface area of a prism is calculated as the sum of the areas of all the faces of the prism. So we have SA for surface area is equal to sigma AF, where the sigma AF is the total area of the faces. So you can just calculate the sum of all the faces of well, this formula actually works for pretty much any 3D shape. So yeah. Now in the case of prisms, this can be generalized further into, so we have the surface area is equal to 2 times A plus P times H, where according to this diagram here, we have A as the area of the base, P is the perimeter of the base, H is the length of the extension of the base itself. Now the visual proof of this may take a while, but it also takes quite a lot of space, so I'll just move into another board. Right, so let's say you unwrap a prism with its base being a polygon with n sides, and that n is unknown and it can stand for pretty much anything, which it could stand for any integer greater than 2. So the net is as shown. So you have two faces or two polygons which have n sides, which are the bases itself. So I'm just call these A. I'm just going to call the area of these n-gons A. And you can recognize the pattern of how many rectangles there are in a prism with a base of a polygon with n sides, and there are exactly n rectangles. So let's just suppose that their lengths or these lengths, or I would say their widths, will be alpha 1, alpha 2, alpha 3, all the way up to alpha n. And notice that the length of the rectangles is exactly equal to the length of the extension of the original prism itself, which is, let's just suppose it is h. And notice you have a relationship that if you refold this back in, all of these line segments will match to the sides of this polygon. And what does that tell us? That means that alpha 1 plus alpha 2 plus all the way up to alpha n is exactly equal to the perimeter of the polygon itself, which I'm just going to call it P. And you can just pretty much see that if you kind of like play around with this nets of polygons. Right, anyways, we can summarize the surface area as the area of all of these polygons and rectangles, which will be 2a. Now why 2a? Because we have two identical copies of these polygons here, one on the bottom and one on the top. And we need to add the areas of the rectangles, which will be the sum of the areas of the rectangles, which will be, well, let's just look at this. So the area of the first rectangle has width alpha 1 and height h. So that will be alpha 1 times h. And you can just do this on and on with different widths as well. So this will go on until of alpha n times h. So these are the areas of the rectangles. Notice that we can just factor out an h out of this. So we have 2a plus h times the whole thing inside will be alpha 1 all the way up to alpha n. And notice that alpha 1 plus alpha 2 plus all the way up to alpha n is exactly equal to p, which we're supposed to be the perimeter of the base of the prism, which is the polygon itself. So therefore, we have our surface area being 2a plus ph. And that completes the visual proof. Now with this in mind, let's just generalize some formulas for the surface areas of the prisms in the last board. The first thing is the rectangular prism, also known as the cuboid. So recall that the surface area is equal to 2 times the area of the base, which is the area of the green region in this case, plus p times c, where p is the perimeter of this rectangular prism. Notice that the area of the green region is the area of a rectangle with width b and length a, which will be 2ab. Simple enough. Plus the perimeter of this rectangle is 2a plus 2b, or 2 times in bracket a plus b, but we're just going to expand it for simple reasons. So 2a plus 2b all multiplied by c. Distributing the c inside the brackets, we will have 2ab plus 2ac plus 2bc. Notice that we can factor out a 2 out of this, so we will have 2 times ab plus ac plus bc. So the surface area is 2 times, what's this? This is like a twofold product of the sides of our given rectangular prism. So that's pretty nice. Next we have the triangular prism. Using our same trick, so the surface area will be 2 times the area of the base, which is the green region, plus the perimeter times the extension length, which is c. And perhaps for simple reasons, I'm going to add some sides just to not confuse you guys here. So let's just say the length of these leaning sides will be x and y. So that will be 2 times the area of the green region. That will be 2 times a half. Notice that the 2 and the half will cancel. So only a times b. So I have ab plus the perimeter here will be a plus x plus y, and we can just expand that out. So we have ac plus xc plus yc. Although remembering this might be difficult, so writing the a plus x plus y in terms of the perimeter itself is pretty okay, I guess. So next we have the cylinder. So the surface area will be 2 times the area of the base plus the perimeter of the base times the extension length, in this case h. So notice that the area of the green region is a circle and its formula will be 2 pi times r squared. Plus the perimeter of a circle is defined as 2 pi r. So 2 pi r times h. Notice that we can factor out a 2 pi r out of here, so we have 2 pi r times in brackets r plus h. And that is pretty nice. Although for the triangular prisms and possibly other prisms with different shapes of as their base, it's okay to represent the p as itself, because introducing some variables as the size of the other size of the polygons will be pretty difficult. So yeah. Anyways, let's jump into some example questions on volume and surface area. Alright, we need to find the volume and surface area of each figure below. So for part A, it is a rectangular prism. So let's see. Well, the volume is pretty simple, which is just the area of the face, or the base I should say, times the length of the extension, which will be simply 81 meters squared times 10 meters, which is 810 meters squared. Meters cubed, sorry. Now to calculate the surface area, we need to find the length of the square here. Notice that this is a square because it has equal sides on here and here. And that is not too hard, because well, notice you can just take the square root of 81 meters squared, and that will give us our side length being 9 meters. And with that in mind, we can just straight up calculating our surface area, which will be 2 times the area of the base of the prism, which will be 81 meters squared, plus the perimeter of the base, which will be the perimeter of a square. And remember that the perimeter of a square is 4 times its side length, which is 4 times 9 meters, which is 36 meters. And after that, multiplied by 10 meters. So this will give us 162 meters squared plus 36. 360 meters squared. And that will give us 522 meters squared. And that's our answer for our surface area. Now for part B, this is a bit interesting. Notice that we have a side length with square roots, and that is on purpose, because well, you can just find this side length here by using the Pythagorean theorem, which you can visualize as a right angle triangle with side lengths 2 plus 6 and 2 plus 6, which is our 8 and 8 respectively, and you'll just get that side length. But in this case, I'll just indicate it for you due to make your job not too hard, I guess. So anyways, the volume of this figure will be the area of the face, the base of this prism times the length, the extension length. Now the area of the base, which is this shaded in blue, is actually the area of, so I just write the area will be the area of a complete right angle triangle with side lengths 8 and 8 minus the cut it off little square right here. So notice that is a square there. So the area of this right angle triangle, and notice its side, here are side lengths, or it should say base 8 and height 8. So that will be a half times 8 times 8. And the area of this little square will be 2 squared, which is 4. And calculating this, you'll get 28. So the area will be 28 times the extension length, which will be 10. So that will be 280 units cubed. Alright, and we need to calculate the surface area next. So that will be 2 times the area of the base plus the perimeter of the figure, the base of the prism, times the extension length, which is 10. Now we have calculated our area before, which is 28. Now for our perimeter is not that bad. So let's just see. The perimeter of the base of this figure will be, let's see. So let's just start with this thing here. 6 plus 2 plus 2 plus 6. So 6 plus 2, 2 plus 6. And then after that we need to add this length, which is 8 times square root of 2. So 8 times square root of 2. And that will be 16 plus 8 times square root of 2. And perhaps you can just factor out an 8 out of this if you're fancy enough, I guess. So we will have 16 plus 8 square root of 2, all of that multiplied by 10. And I'll let you guys do all of this to find out the arithmetic of this answer. And that will be this video. So hopefully you guys enjoy this. Please subscribe for more videos, and I'll see you guys in the next video. Goodbye.